All right, hi everybody. So we've got another video here. I'll probably say this again a little bit later, but just so you guys know, we are still in the 10.8 section talking about equations of circles. But I did want to talk about something like this before we get into some of the new stuff that we're going to talk about. For anybody who was at the Google Meet session, I believe on the 18th, you might have been there when we were talking about how to do completing the square, which you guys should remember from Algebra 1. So I want to talk about that really quick before we go into the new stuff. So when you're solving equations by completing the square, your actual quadratic is going to look a little bit different than this, like how you're used to. The format that you want for completing the square looks something like this. X squared plus bx is equal to c. Instead of everything over on one side, you want all the variables on one side and then any constants or numbers on the right. So in this case, the only extra work that we'd have to do before we get started is just shift that 45 over. X squared plus 18x is equal to negative 45. All right? Now the goal here is to make this look like a perfect square trinomial, all right? If we still wanted to try to factor this left side, we would need a different c term after the 18x, not that 45, and you'll see why in a minute. But what I'm talking about is something like this, right? If we had some kind of number there, this would then look like a quadratic trinomial that we would then be able to factor. But if we're adding this blank space on the left, that means we would have to add the exact same blank space on the right-hand side. All right? And the question is, how are we going to figure out what goes into that blank space? Well, there is a formula that you guys learned, hopefully, in Algebra 1 that was b over 2 squared. And what's our b value? Well, it comes from up here. B is the coefficient in front of the x. All right? That's the formula to figure out what number goes in this blank space. So if our b value is 18, 18 divided by 2 is 9, and 9 squared is 81. And since we're adding 81 on the left, we're going to add 81 on the right. All right? So we are easily able to simplify that right-hand side. Negative 45 plus 81 is 36. All right? And then we can factor the left. What are factors of 81 that add up to 18? 9 and 9. The whole reason why this works and why it's called completing the square is because you should get things like that. All right? Factors of 81, 9 and 9, all these perfect square numbers that help you set up your binomials accordingly. So, again, factors of 81 that add up to 18 are 9 and 9. So, that would be x plus 9 and x plus 9. And the whole reason why I'm doing that over here instead of on the left side of the equal sign is because I have mentioned this to you guys before. A simpler way to write this final answer, because it's the exact same binomial twice, x plus 9 squared. All right? That's the factoring part of it. Now, how would we actually solve this? Well, if you have an entire binomial squared, to undo that exponent, you would just take the square root of both sides. That cancels this out, and then x plus 9 is equal to the square root of 36 is 6. But one thing I had mentioned in the Google Meet session is that when you're taking the square root, you should get, or you have two possibilities, right? We know 6 times 6 is 36, but we also know that negative 6 times negative 6 is 36. So you need to incorporate both of those possibilities when you're solving. And what I mean by that is it could be positive 6 or negative 6. That little plus minus when you're taking square roots of numbers. Because when you're solving quadratics in general, you should typically get two answers. All right? So then how would we go from here? Well, if there are two possibilities where one is positive and one is negative, we're going to break this up into two separate equations where we can solve for each of those possibilities. X plus 9 is equal to 6, and x plus 9 is equal to negative 6. And then solve both of those for x. So this is going to be negative 3, and this is going to be negative 15. If you tried to factor this and then solve, you should have gotten the same thing. But the whole reason why I wanted to talk about completing the square is because you're probably going to see stuff like this in the notes that we talk about today. All right? Because like I said, we're still talking about equations of circles. Again, this is 10.8. I'm honestly not sure how much of this shows up in the textbook, but if you need resources, that section is where you might be able to find it. Because, well, these are the kinds of questions that we're going to start off talking about. This is general form of an This is general form of the equation of a circle. Yesterday, we talked about standard form, which is x minus h squared plus y minus k squared is equal to r squared. And the whole reason why I brought up completing the square before is because if I go back to the warm-up, kind of like there, a portion of our completing the square problem looked similar-ish to standard form of the equation of a circle. I can't fit it all in the same screen, I think. Sort of. It sort of looks similar in format. So, if this is general form of the equation of a circle, how would we rewrite this in standard form? We're going to have to complete the square. So, if you remember from the last problem, we have to get this constant over to the other side. So this is going to be equal to negative 17. Now the problem is then we have the rest of this in terms of two variables. So we're actually going to have to complete the square twice. Once with x and once with y. So before we even get into that, I'm going to rearrange this a little bit just so all the x's are together and all the y's are together. So all that's going to be is x squared minus 6x and then y squared plus 8y. All right? So if we're completing the square for both x and for both x and y, that's why I left these spaces here. Because we need a plus blank for both of them. And if we have two blanks here, that means we're going to need two blanks on the right side as well. So how do we fill in each of those blanks? Well, it's exactly the same way that we filled them in earlier. B over 2 squared. So in this case, our b is negative 6. So negative 6 over 2 is negative 3, and negative 3 squared is positive 9. Because you're squaring stuff, you should always get positive numbers. That's why it's always a positive, or plus blank. 8 over 2 is 4, and 4 squared is 16. So that's how you would fill in each of those blanks. And we would fill in the blanks on the right exactly the same way. I also forgot to tack a little bit plus sign there, and that is going to be really important in a minute. But now we can factor each of these polynomials separately. Actually, let's simplify the right side because that's super easy. Negative 17 plus 9 plus 16 is 8. Okay? So we're going to factor x squared minus 6x plus 9. What are factors of 9 that add up to negative 6? Because we're dealing with completing the square, these should be exactly the same number. So it's going to be 3 and 3, but because we want it to be negative, it's negative 3 and negative 3. So x minus 3, or x minus 3 squared. Plus, that's why I tacked that plus sign in here, and then we're going to factor this down. What are factors of 16 that add up to 8? 4 and 4. So y plus 4 and y plus 4, or y plus 4 squared. Little hint, I don't know if your Algebra 1 teachers told you this, but what number is actually going to go in here? Just b over 2. Negative 6 over 2 is negative 3. That's what goes here. 8 over 2 is 4. That's what goes here. Little trick for you. And that's standard form of the equation of a circle, which is part of what we were asked for. All right? So that's part 1. Identify the center and the radius. Well, if this is standard form of a circle, where h comma k is your center and r is your radius, we can figure out all of that from the actual equation itself. For the center, we just have to make sure to switch the signs, like we would when we plugged it all in. So your center is 3 comma negative 4, and your radius, since this is r squared, your radius is the square root of this, so it's the square root of 8. And I mean, it might be a good idea to break down that radical. All right? So there you go. There are a couple more problems in here. So that's that. Okay. And I'm going to do this exactly the same way I did the last one. Bring the 4 over. Rearrange the left-hand side just so the x's are clumped together and the y's are clumped together. So x squared plus 2x, leave a little space, plus y squared plus 4y, and we'll put something in that space. Completing the square. So what needs to go in those spaces are plus blanks. And I didn't leave myself much room, so I have to squeeze them in. If we have 2 plus blanks on the left, excuse me, we're going to need 2 plus blanks on the right. So how do we fill in those blanks again? B over 2 squared. In this case, B is 2, so 2 over 2 is 1, squared is 1. 4 over 2 is 2, squared is 4. So 1 and 4 go on the right as well. And negative 4 plus 4 actually cancels out. So the right side leaves you with just 1. And then we're going to factor both of these trinomials again. Factors of 1 that add up to 2, 1 and 1. So x plus 1 and x plus 1, or x plus 1 squared. What are factors of 4 that add up to 4? 2 and 2. Don't forget that plus sign, because that's necessary for standard form. There you go. Okay. And now we have all the information to actually answer the second part of the question. Identify the center and the radius. Center, switch the signs, -1, -2. And the radius is the square root of 1, which is nice this time. It's just 1. All right. These are pretty complicated, so I actually, I'm sorry if this video ends up being really long, but considering we had a lot of questions about equations of circles in general, I do really appreciate you asking all the questions and helping each other out. But I think it might be helpful if we went through just one more and then we're going to do something else. All right. So none of this is different from anything that we've done up to this point. Bring the 15 over. We're going to rearrange the left side so that all of the same variables are next to each other. So x squared plus 8x, leave a space, plus y squared plus 2y. We're going to complete the square, so we're putting plus blanks in those spaces, and that means we need plus blanks on the right. What goes in those plus blanks? B over 2 squared. So if our B is 8, 8 over 2 is 4, squared is 16, and we did this in the last problem. 2 over 2 is 1, squared is 1, so those numbers are going to get filled in on the right-hand side as well. And now we factor. What are factors of 16 that add up to 8? Again, it should be exactly the same thing, or the same factors, 4 and 4. So x plus 4 and x plus 4, or x plus 4 squared. what are factors of 1 that add up to 2? We did this in the last problem. It's 1 and 1. So y plus 1 squared. And then, again, simplified this first last time. So negative 15 plus 6 is 1, plus 1 is 2. That's standard form. And then again, we have all of the information we have the means to figure out the other necessary information that the question is asking us for. Center, we have to switch the signs of your h and your k. So it's -4, -1. And your radius is the square root of r squared. So the square root of 2. And that you can't simplify. So we're done. All right. Again, leave all your questions in the question forum. Or if it's something like quick, we have Hangouts. But one more thing I want to talk about is something like this. Given that circle, does that point lie inside, on, or outside the circle? So we saw yesterday and in the last couple of problems that this standard form equation tells you two things. It tells you the center and it tells you the radius. And what again is the radius? Well, it's the distance from that center to any point on the edge of the circle. So, since we have a point, we can plug that in for x and for y. 2 minus 3 squared plus 3 minus 4 squared. And we want to see, does that equal 13? Because if this point is on the circle, it's going to equal 13. If the point is inside the circle, it's not quite going to reach that 13. All right? So we'll probably get something less than 13 because it's not going to quite get there. And outside the circle then it goes beyond that 13. All right? So if we get something greater than 13, that's outside the circle. Again, 13 is not actually the radius of the circle. The radius is the square root of 13, but same kind of thing would still be true. All right, if it doesn't quite reach that number, it's inside the circle. If it exactly hits that number, it's on the circle, so we can put an equal sign right there. And if it goes past that number, then it's going to be outside the circle. So then what does this get us? Well, 2 minus 3 is -1, squared is 1. 3 minus 4 is also -1, so square that is 1. That's 2. So how does that compare to 13? Well, it's less than 13, so it doesn't quite get there. So this point 2, 3 is inside the circle. All right? Okay. Exact same question, just with different numbers. So we're going to do the exact same thing all over again. Plug this point in for x and for y. So -1 minus 2 squared plus 2 plus 3 squared. And we want to see how that compares with this 9. If it's less than, it's going to be inside. If it's equal to, it's on. And if it's greater than, it's going to be outside. -1 minus 2 is -3. Squared is 9. I think I already know where this is going then. Plus 2 plus 3 squared is 5. Squared is 25. Yeah, that is definitely way bigger than 9. So this point is outside the circle. Okay? I believe this is the last one. And slightly different this time. We have a center, but we don't have a radius. We don't have an equation. So maybe we could actually try to write an equation given this information about the circle. Given a circle with center 3, 1, okay, that's a good start, and a diameter 10 units long. Well, how does the radius compare to the diameter? It's half of it. So if the diameter is 10, your radius is going to be 5. And that's enough to plug into standard form so we can actually write the equation of the circle. X minus 3 squared plus y minus 1 squared is equal to r squared. So 5 squared is 25. And you do have to make sure to fully simplify that. There were a bunch of people who just kind of would leave something like that as 5 squared on the Google form yesterday. Please, please, please simplify 5 squared to be 25. All right, so that's our standard form, and then we can actually figure out the answer to the question by plugging this point in. 3 minus 3 squared plus negative 4 minus 1 squared. How does that compare to 25? Well, this is going to be 0, and this is negative 5 squared, which is 25. So because of that, this point lies on the edge of the circle. Oop. All right. So go back to the beginning. That's it for today. Yeah, I think you guys are getting the hang of this so far. Please check Classroom for your homework. And you've seen all the different options at this point. Form, bookwork, or a worksheet. You guys have been really good at sending everything in a timely manner, so please continue to do so. And yeah, I hope everybody's enjoying online learning so far. I hope everybody's staying healthy, safe, clean, etc., etc. And I'll talk to you guys soon.